Hello, Algebra 2 Part 2. This is the second day of 851, so more practice in solving nonlinear inequalities. So in the last class, we focused mostly on solving quadratics. So those were polynomials that had the greatest exponent of 2, or they had 2 factors in them. And so in this class, we're going to take things a step further. We'll do some cubics, and we'll do some rational functions. The process is still the same, so we still want to break things down into factors, find our zeros, and put those on number lines, on a number line, and then figure out where it's going to be positive and negative. Okay, so we'll get right into the classwork. So I'm pulling these just right from the handout that you should have downloaded on this. So we'll start with number 7. We have x plus 5 over x minus 1 is greater than 0, okay? So the two factors that we're going to be considering here are x plus 5 is 0 and x minus 1 is 0. So this one is nice because the rational expression is already factored, so we don't have to think too much about it, so we can just take them separately. And we'll solve this. So I'll go ahead and subtract 5, and I'll get x is negative 5, and then add 1, and x is 1, okay? So then I have my test values that I can go ahead and plot. So let's see, I'll have negative 5 and 1. So I'm sorry, those aren't test values, those are zeros. So I can go ahead and pick my test values now. So let's see, I can use negative 6, 0, and 2. And so now we'll plug those test values into the function, the original function. So I'll have negative, let's see, I'll give myself some space here. I'll have negative 6 plus 5 over negative 6 minus 1. And then I'll have 0 plus 5 over 0 minus 1. And then I'll have 2 plus 5 over 2 minus 1. All right, so going ahead and solving this. So at this point, what we want to do is figure out where it's going to be positive and negative. So negative 6 plus 5 is a negative, negative 6 minus 1 is a negative, and a negative over a negative is a positive. So we're positive on the left side. 0 plus 5 is a positive, 0 minus 1 is a negative, so positive over negative is a negative, and we're negative in the middle. 2 plus 5 is a positive, and then 2 minus 1 is a positive, so we're positive on the right side, okay? So the original problem wanted to know where we were greater than 0. Greater than 0 means we're positive, so that's going to be on the left side and the right side. And so how we can write that with inequalities for our answer, we can say that x is less than negative 5 or x is greater than 1. And so that's our answer for number 7. So we'll go on to number 8. So for 8, we have a cubic. Whoops. So for 8, we have a cubic. We have x plus 3 times x minus 3 times x minus 2 is greater than or equal to 0. So we break all of these up, set them all equal to 0, and then we'll go ahead and solve. We'll get a negative 3 for x, we'll get a positive 3 for x, and we'll get a positive 2. So we're going to put all of those on our number line. So I'll have negative 3, 2, and 3. And then my test values will be negative 4, 0, 2.5, and 4. Okay? And we'll go ahead and we'll plug all of those test values into the original function. So let's see, I'll have negative 4 plus 3, negative 4 minus 3, and then negative 4 minus 2. I'll do 0 plus 3, 0 minus 3, and then 0 minus 2. I can do 2.5 plus 3, 2.5 minus 3, and 2.5 minus 2. And then I'll do 4 plus 3, 4 minus 3, and 4 minus 2. Okay, so we can simplify all of these. So starting on the left side, so let's see. Negative 4 plus 3 is a negative, negative 4 minus 3 is a negative, and negative 4 minus 2 is a negative. So if you multiply out 3 negatives, you'll get a negative. So we'll be negative in that first zone there. 0 plus 3 is a positive, 0 minus 3 is a negative, and 0 minus 2 is a negative. So in here, positive times negative is positive, and so we're positive in our second zone. 2.5 plus 3 is positive, 2.5 minus 3 is negative, and 2.5 minus 2 is positive, so that answer is going to be negative. 4 plus 3 is positive, 4 minus 3 is positive, and then 4 minus 2 is positive, so that will be positive. So the original problem, we want to know where we are greater than or equal to 0, so that's going to be where we're positive, and so that will be between negative 3 and 2, and to the right side of 3. And notice that the original problem has it written as greater than or equal to, so we'll include that when we write our answers. So our answer will be, this range here between negative 3 and 2, we'll write that out as negative 3 is less than or equal to x is less than or equal to 2, or, and then the second range here, well, it's greater than 3, so we'll say x is greater than or equal to 3. And so this is your answer here. Now, because we included the greater than or equal to sign in the original problem, we'll include that in our answer, okay? So number 9 is also another cubic. We'll go on to number 10 and see what that one's like. So for 10, we have another rational function. We have x plus 3 over x is greater than 0. All right, so we can take our two separate factors. So I have x plus 3 is 0. Now, your denominator, if we were to take the denominator and set it equal to 0, well, that's impossible because if our denominator, if x was 0, then your denominator would be 0, and that would be undefined. So for this particular problem, we don't even really worry about x being equal to 0 or trying to solve that one. But we'll have to deal with that in just a moment. So something that we do want to say is not necessarily that x is equal to 0, but we'll say that x cannot equal 0, and that's because it would make the denominator 0. Okay, and we'll have to talk about what that turns into in just a minute. So if we go back to the other factor, x plus 3 equals 0, and solve that, well, I'll minus 3, and x is negative 3. Okay, so what we want to plot on our number line here, let's see, we'll have a negative 3, and I'm going to put 0 on. The reason why I'm going to put 0 on is because we know x cannot equal 0. So I'm going to put a big red circle at it to remind me I can't equal it. And so we'll see how this comes out. Now, we've got to pick some test values. Okay, so we'll do, let's do negative 4. We'll do negative 1, and we'll do 1. Okay, and then we'll go ahead and we'll plug our test values in to the original function. So I'll do, let's see, negative 4 plus 3 over negative 4, negative 1 plus 3 over negative 1, and then 1 plus 3 over 1. Okay, So simplifying some things. So negative 4 plus 3, that'll give me a negative. And then over a negative 4. So a negative divided by a negative is a positive. So we'll have a positive right there. A negative 1 plus 3, that'll be a positive over a negative. So a positive divided by a negative is a negative. So we'll have a negative there. 1 plus 3 is a positive. 1 is positive, so positive divided by a positive is positive, so we'll have a positive on the right side. Now the reason why I had to put 0 on and use that as a divider between the two ranges is because we know x cannot equal 0 because it would make the denominator 0. And so you also have to look out for values that would be undefined in these types of functions. Now the original problem, we want to know where is greater than 0, so where it's positive, and that'll be to the left of negative 3 and to the right of 0. And so how we would write that out is we can say x is less than negative 3 or x is greater than 0. And so that's our answer for number 10. We'll go on to number 11. So for 11, we have x squared is less than or equal to 16. So this looks different than all the other ones that we've done so far today. We can go ahead and solve and factor this one if we get it set equal to 0. So I'm going to minus 16 from both sides. So now I have x squared minus 16 is less than or equal to 0. So now this is starting to look more like the other problems that we've worked with. So then we'll go ahead and factor that. That's the difference of two perfect squares. So x plus 4 times x minus 4. And then we'll split those up. So we'll have x plus 4 is 0, x minus 4 is 0. And we'll solve each one of those. So x is negative 4. And then x is a positive 4. And we'll go ahead and put those on the number line. And so we'll have negative 4 and positive 4. We can pick some test values. We'll do negative 5, 0, and positive 5. And we'll go ahead and plug those in to our, to the x plus 4 times x minus 4. So let's see, I'll have negative 5 plus 4 times negative 5 minus 4. I'll have 0 plus 4 times 0 minus 4. And then I'll have 5 plus 4 times 5 minus 4. So negative 5 plus 4 is a negative, negative 5 minus 4 is a negative, and negative times a negative is a positive. So we're positive on the left side. 0 plus 4 is a positive, 0 minus 4 is a negative, positive times negative is negative, so we're negative in the middle. 5 plus 4 is a positive, 5 minus 4 is a positive, positive times positive is positive, and so we're positive on the right side. So if we go back to this step, to where we had it set at 0, or even here where we had it factored, we wanted to know where we were less than or equal to 0, so where we are negative. And so that's going to be in the middle zone here. And so how we can write that out with an inequality is we can just say that negative 4 is less than or equal to x, which is less than or equal to 4. And the reason why I use the less than or equal to sign is because that's what I have in the original problem. It's got the line under the inequality. So negative 4, less than or equal to x, less than or equal to 4. Now, we'll go on to number 12, which is very different. So for 12, we have 2x over x minus 3 is greater than 1. So again, we're going to want to get this set to 0. So let's see. So we'll minus 1, minus 1. So now I have 2x over x minus 3 minus 1 is greater than 0. Now, if we look at this, we could take this 1 over 1 and put it over our LCM, or our common denominator. And if we kick this up here, our LCM is just going to be x minus 3. So I'll have 2x over x minus 3 minus, and then I'll have x minus 3 over x minus 3, and this is greater than 0. Now, what we can do is go ahead and combine things. So this is going to turn into, and this is tricky. You have to imagine parentheses around this, and that means you're going to have to distribute that negative. So if we turn this into one rational expression, we're going to have 2x minus x plus 3 all over x minus 3, and then that's greater than 0. So if we take this one step further to simplify, well, 2x minus x is a positive x, so I have x plus 3 over x minus 3 is greater than 0. So now this is starting to look more like the problems we started with at the beginning of the day. So I can go ahead and separate those. So I'll have x plus 3 is 0, x minus 3 is 0. I'll solve each one of those. So I get x is negative 3 and x is positive 3. So I'll go ahead and get my number line going. And I have negative 3 and positive 3. Okay. And let's see, I'll do negative 4 for my test values, 0 and 4. And I can plug these numbers in. When I go ahead and plug these numbers in, I'll plug them into this right here. I can test them out in that. So let's see, I'll have negative 4 plus 3 over negative 4 minus 3. I'll have 0 plus 3 over 0 minus 3. And then I'll have 4 plus 3 over 4 minus 3. So go ahead and simplify these. So negative 4 plus 3 is a negative. Negative 4 minus 3 is a negative. And a negative times a negative is a or negative divided by a negative is a positive. So I'm positive on the left side. 0 plus 3 is a positive. 0 minus 3 is a negative. So positive divided by a negative is a negative. So I'm negative in the middle. 4 plus 3 is a positive. 4 minus 3 is a negative. And positive divided by a negative. 4 minus 3 is a positive, right? So positive divided by a positive is a positive. So I'm positive on the right side. Okay, so if we go back to this step here, we said we were greater than 0. That means we're positive. So we're talking about the left side and the right side. So writing that out with an inequality, we'll have x is less than negative 3 or x is greater than 3. And that's our answer. And we're all done with our classwork. And so hopefully you know enough to go ahead and try the homework on your own.